Good morning and thanks for joining. I'm Sahdev Zala, a software developer with IBM. I'm also co-founder and PTL for the Heat-Translator project. I'm here with Matt, who is the chairman for TOSCA Simplified Working Group, and he's also lead editor for the TOSCA specification. So Heat-Translator project and TOSCA has been widely discussed in the previous summits in Atlanta and Paris, so we're not going into much detail of what they are, but what we would like to do today is, after an overview, we want to provide an updates on the progress we made after the Paris summit and the plan for the Liberty release. Matt will do the same for the TOSCA. I'll be doing it for Heat-Translator. Just as a high-level overview of the project, Heat-Translator project was created as a StackForge project early last year, with a goal to create a translation layer, a tool that can take literally any format and convert it into the heart, the Heat Orchestration Template. Its primary focus on TOSCA right now. As you see, the main two components are TOSCA parser and heart generator. TOSCA parser takes the TOSCA template and it creates an in-memory graph showing the relationship and dependencies between nodes, etc. And the generator takes the in-memory graph and it maps it to the heat resources and basically creates the hot template, and that's what you get it as an output. You can basically then manually deploy the template using Heat, and you're good to go. One of the future plan is programmatically invoke Heat, so that it will be like one-step, deployment, translation and deployment together. Anyway, so coming on the progresses we made since Paris Summit, we reached an important milestone when the project was officially became an OpenStack project. So proud of that. It's now an officially OpenStack project under the Heat main program. There are a couple links there for the source code repository and documentation. A lot of things has been achieved during the kilo release cycle. Very proud of the team. The main accomplishment includes implementation of the new TOSCA features as they were added in the TOSCA specs, networking, block storage, object storage, new capabilities, something Matt will be covering. We also made the tool available on command line. It's more for like to play with the tool. And we'll be doing more effort there to make it more sophisticated for usage. We now support the user input parameters. So user have no option to provide the parameters on command line when they use the Heat-Translator tool. And that will be resolved if they don't want to use it. They can use it when they deploy the translator template with the Heat. Other thing is the TOSCA ecosystem is growing. We added a lot of use cases with new features like networking and on storage and multi-tier use cases. Something I'm going to covering in the next few slides. Also, implementation for TOSCA relationship templates and custom types. Relationship templates are basically reusable template relationship definitions you can use between across different nodes. And TOSCA supports it provides a rich set of base type definitions, but per your application needs, you can always create your custom types, extending the base types. So as I was saying, that now the tool is available on command line to use. You run the project and you just run the Heat-Translator Python program, which basically takes two arguments. Template file is the file that you want to translate, and we have another parameter to basically describe the type, which is TOSCA. But it can be anything in future, depending on the support, the future support. And you can provide the parameters as well. Just an example on the left side is the most basic TOSCA template, hello world template, which just creates a compute instance. On the right side is the output of the hello world from the command I just mentioned on the top of slide. One thing you notice here is on the TOSCA template, TOSCA allows constraint-based selection for the flavor and for the operating system. We have an algorithm to find an image based on those constraints, and those are the one set in the in the Heat. Right now we're doing the best match to the constraint, and it's working good. We have two important plans for the Liberty release. The first one is implement Cliff. Cliff is command line interface formulation framework. It's a framework to build user-friendly command line programs. Many of the OpenStack project, they implement Cliff. Some of them are not, but I heard during this last 3 days they will be. And for us, it's a perfect fit as we just started the command line support. The second thing, I've been talking, and the whole team has been discussing it with the folks in the Heat, to make the tool available, to do basically invoke the Heat client to run certain commands programmatically. So I think in last 3 days discussion, what we came out is, we will do through the OpenStack client. It's an unified client, basically created pretty much for all the projects. It supports, I think, 5 or 6 base programs, but the other programs or projects we need to use OpenStack client basically creates a plugin, and that's the way to go. So we will be creating plugin as well. So I want to touch with one of our multi-tier TOSCA use case. We have it's in like 2 parts, but the first part is you see the TOSCA modeling of a typical application deployment workload. It's basically consists of 3 components: PayPal Pizza Store application, Node.js, and MongoDB as a database. The PayPal Pizza Store application lets user to play with the REST APIs to store their credit card information, to order pizzas. And with the TOSCA modeling, as you see, the application needs a container, and Node.js, which we use in web server, provides that capability. So it's been fulfilled by the Node.js. So the application is hosted on the Node.js, which itself needs a virtual server, so which is hosted on an application server. And the application is using MongoDB as a backend database. The TOSCA Node database is where we create a database, which is required by the application, and it is hosted on DBMS node. That's where basically we create or install MongoDB, configure it, and make sure it's up and running. And it itself is hosted on a Mongo virtual server. Going forward, the second part is basically we extended the use case with logging and monitoring tier. It's an Ulk-Stack. So we have 3 more components now: Logstash, Elasticsearch, and Kibana. They all have, they've been created as in like custom types because they need to provide, or they provide their own capabilities, like log, endpoint to connect to the Logstash. Elasticsearch has its own endpoint, so that Logstash and Kibana can be connected to it. The other thing I would like to mention is the application server. That's where you see the 2 new components, collected daemon and rsyslog are installed. For the sake of brevity, I haven't provided the modeling here, but they are installed with the same modeling of, they're hosting basically on the app server. And collected and rsyslog basically, collects the log and sends to the Logstash server. And basically Logstash is connected to Elasticsearch. Kibana is also connected. Elasticsearch is what performs indexing and searching. And then you have Kibana, it's a dashboard to basically monitor your application server. You can do this with you can add those collect D and rsyslog or any other basically those agents onto different nodes, even on the database node or even Logstash itself, Elasticsearch. So those are all then can be monitored. We have done this with more than 20 scripts. So very proud of the team. And we will be one of the plans for the Liberty is to include and to create more such use cases. Basically real life use cases. We're talking with different users of the Heat Translator from the folks in TOSCA Technical Committee, and we'll be creating having more use case available made during the Liberty release. Well, that is pretty much from me. Thank you so much, and I will hand it over to Matt.
Thanks, Sahdev.
Sure, thanks.
So Sahdev showed one of our more recent templates we added that features our multi-tier use case using many open source components that are found in typical applications. I want to take you through a tour of some new functions we've added in Kilo, and which represent TOSCA node types and relationships that we've added in the version 1 spec, and now we have templates for in Heat Translator. Some new features we added in the Kilo release are support for templates and for block and object storage. For example, here's one of them represented here in this model. We have a web server that wants to connect to storage, so they can actually define an attachment to that storage and define a mount point. And we could actually add a second web server node and attach it through a separate connection to a different mount point to the same storage, and they can share that. We've also added network modeling in OpenStack, so you can actually model your network separate from your applications. You can define public and private networks that bind to different stacks, and they infer routes based on the model. You can actually, if you want to, model explicit routes if you want to, or add load balancers to the model. In addition, going forward, we're just starting to add templates for container support. You'll see some stuff for like Docker and other container technologies. What's cool is on the left, we're able to, in TOSCA, simply model a platform. Many people want to export a platform as a customer and indicate what types of applications they support. For example, you see a Docker application being supported in a Paas platform, a Node.js, J2E applications. And in TOSCA, it's cool because you can just model the right side. You can say, I have a Docker container, here's my Docker image, and you export a requirement for Docker to the platform, and TOSCA Heat Translator will automatically find the two and match them up, the requirement of the application to the capability of the platform. Going forward, you're going to see policies implemented in new templates in the areas of placement or affinity, co-location, anti-location, being able to do availability zones and regions. We're going to do scaling policies that talk about how you scale tiers, scale horizontally, vertically, and also performance policies that may trigger scaling policies. We can detect performance. We can set thresholds that are registered as telemeter for alarms. We can get notified to execute triggers that execute new scripts or import new templates and execute those. You can see we can attach policies at different levels. We can attach policies that get triggered on individual operations like a create or configure operation, or at a node level. So when the node gets instantiated, we can trigger a policy. Or if you group nodes together, so you have a ratio or a thing applies, a policy that applies to multiple nodes, you can attach a policy to that grouping. We have NFV support, so we can now model NFV in TOSCA in templates. We can do virtual network function descriptors and create graphs. We can model connection points, so we're just adding support for forwarding graphs. As you can see, we can model in TOSCA on the right all the different constructs in NFV, such as E-lines, E-lands, and E-trees. We're going to have to figure out over time, because Heat Translator can't do these things with Heat currently, but we'll work with the Heat project to enable perhaps NFV to be supported through Heat Translator. In conclusion, I would just like to say that watch Heat Translator. We're going to be adding more and more templates through the Liberty release. We're also going to be with the Murano team to add our TOSCA templates to the new service catalog. So you'll be able to launch them from there. So thanks very much.
Thank you.